Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi, everybody. Welcome to test number 3 review. Remember, this Thursday, I'll be giving test number 3. I'll send out in the morning the email with the password that allows you to open up the password protected PDF file that will be on D2L. And you'll have until Friday, 4 p.m. to upload your answers as a single PDF file. And if you have any questions, feel free to email me during the test. All right, let's get going. Now, the following review file, what you're seeing on the screen, is in D2L in the lecture section of D2L. You may, if you go to the bottom of the files in that lecture section, may have to click on, I think the button says more, and to see this file. All right, let's get going. And let's start out. What is a carboxylic acid? It's a carbonyl, carbon double bond to oxygen with a hydroxyl group, OH, and an R group on it. Now, how do you name carboxylic acids? You find the longest chain with the carbonyl carbon, carbon double bond to oxygen, name it as an alkane. Drop the E, add OIC in the word acid, and remember, the carbonyl carbon of a carboxylic acid is always number 1, so we don't put that number 1 in the name. And all the rest of the alkyl groups you number and name like you've always done it, with the understanding that the carbonyl carbon is number 1. Now, there's some common names, excuse me, you should know. And common names, I will never ask you what is the common name, but I will give you the common name and ask you to draw it. And there are 3 I'd like you to know. One is when R is a methyl group, that's acetic acid. And you should remember that acetic acid and water, that's a product you have in your house most likely. 4% acetic acid, and about 96% water. You mix together, you get a homogeneous solution, and we call this vinegar. If you look at ketchup, mustard, or relish, the special Chicago glow-in-the-dark green type, which I love on hot dogs, that all has vinegar in it. Now, when R is a hydrogen, you have formic acid right here. And that mixed with water and heated up is the defensive weapon of the fire ant. And finally, when R is a benzene ring, this carboxylic acid, IUPAC in their infinite wisdom said, we're not going to change those organic chemists. They've been calling this benzoic acid for eons. We'll make that the official IUPAC name. And they did. Now, why is this called an acid? Because an acid is a proton donor. And if you remember your basic chemistry, I hope you do, acid plus a base, you have proton transfer, and you make a salt. The 2 of these together make a salt. So general reaction, you should know, if I take a hydroxide base, MOH, where M can be lithium, sodium, or potassium. There are other ones, but for this class, this is all I'm asking you to learn. And you react it with a carboxylic acid, you'll get this carboxylate anion or salt. And you don't have to write the charges I do, because I think it's cool, isn't it? Yes, it is. But you should know the H on the OH of the carboxylic acid is acidic. Now, a special reaction, if you take a carboxylic acid, react it with sodium bicarbonate, which you can find in baking powder. You get the carboxylate anion, but this is one of the few reactions I also asked you to write all the products. And you also get water and carbon dioxide, which is a gas. And I show that by the arrow pointing up. And if you watched a video, which I hope you did, you learned the story about how my father taught me how to, in those, remember those little rockets, they had the awful candy in? You dumped the candy in the garbage can, it was that bad. You know it's bad if a 5-year-old won't eat candy. And my friends didn't either. Oh, it's awful. But you got the little rocket ship. You took the cap off where the candy was, which was the shell upper part of the rocket ship, put some vinegar, when ours methyl, that's acetic acid, and baking powder, put it in there, put the cap on, mix it, hold it, and in there you get this reaction where R is methyl, and it builds up the carbon dioxide to enough pressure, it shoots the cap off. See, I'm smiling, I can still picture me doing that. God, how many decades ago was that? Lots. But anyways, all right, how do you make a carboxylic acid? You take a primary amine, I'm ahead of myself, primary alcohol, oxidize it, that's with the O in the bracket, and you convert this to a carboxylic acid. The carbon with the hydroxyl is the carbon of the carbonyl of the carboxylic acid. Now, you can also take an aldehyde and oxidize it. This H becomes an OH. Now, a really neat, cool way of doing it, making a carboxylic acid, is a reacting, and now you know I'm happy because I love Grignard reagents. A Grignard reagent where X can be chlorine, bromine, or iodine with carbon dioxide, second step water and acid, H plus is acid, like H2SO4, other acids, and you get a carboxylic acid that's one carbon longer than the R group you started with, and the carbonyl carbon in the carboxylic acid will be attached to the R carbon in the R group that has the MgX on it. All right, next I talked about a derivative, something you can make from a carboxylic acid, and that's an ester. You have a carbonyl, carbon double bond to oxygen, with an R group here. And then on that carbonyl, you have OR prime. And the R prime just tells you R and R prime can be the same or different. That means this has carbons and hydrogens in it for this class. Now, how do you name an ester? Well, in the front, you name the R prime group as the alkyl group it is, like methyl, ethyl, and so on. Now, there are two ways you can name the rest of this. 2A, which is the IUPAC method, assume R prime is H, name that as a carboxylic acid, and drop the IC in the word acid and add OAT. And remember, the carbonyl carbon is always going to be one, but my gift to you this semester, I won't put any alkyl groups on R. Now, years ago, I had a really sharp 170 student, and that student came up with, well, for almost most of the carboxylic acids, you can name it this way, which I call B2. If I say 2B, I'm going to have to say 2B or not to be. That's the question. But anyways, hope you know your Shakespeare. And his method was name R prime as the alkyl group in front, like you've done for the IUPAC, but now name the carbonyl carbon in R as an alkane, drop the E and add OATE. And this works, except for when R is a benzene ring, then you can only use 2A. All right, now I only asked you to learn one common ester. And that ester is ethyl acetate. Nobody calls this ethyl ethanoate. And here's the structure. And remember, this is the molecule, one of the molecules that is used in nail polish remover. It won't be on test 3, but you learn for test 2, acetone is another molecule used for removing nail polish. As you can see, I forgot to polish my nails. Don't look. All right. Now, while we're talking about esters, let's talk about the nomenclature of carboxylate anions, which is this structure right here. And here, how do you name them? Well, it's about the same as an ester, but there's a slight difference. The M plus you name as the element it comes from. So if M plus is Li plus, that's lithium, so that'd be in the front, or sodium, or K, potassium. And the rest of it, this part right here, you name just like you did in ester, either A, 2A or B2. Now, if you were coming into spring, I'd say, now we're coming out of spring and fall. It's almost just about winter coming soon. Yep, Thanksgiving is only 2 weeks away, I think, or a week and a half. But remember, esters are responsible for the smell of most flowers. Next time you smell a rose, you're smelling esters, very complex mixture of esters. And esters are responsible for the taste and smell of many fruits and vegetables. Yes, it is. And if you like bananas, I don't, but it's still an interesting smell. You're smelling and tasting an ester. Excuse me. Now, how do you make an ester? You react the carboxylic acid with an alcohol in the presence of acid, H plus, like sulfuric acid, H2SO4, and you form an ester. Now, on the OR prime, this oxygen is bonded to the carbon in R prime that had the hydrox group. Again, in the ester, the OR prime, the oxygen is bonded to the carbon in R prime here that had the hydroxyl group and the alcohol here in R prime here. Now, what can you do with an ester? Well, it turns out this reaction right here, acid hydrolysis of an ester, H plus and water, you get back the carboxylic acid and the alcohol you would have used to make that ester. And we'll learn later on, this reaction is how your stomach breaks down fats and oils. We'll get into that. That's in the industry I work in, fats and oils, but you'll just have to wait for that. But remember, the carbon in R prime with the oxygen here will be the carbon in R prime with the hydroxyl group here. I'll say it again. The carbon in R prime with the OR, with the oxygen bond to it, will be the carbon bonded to it here in the R prime of the alcohol. And what's attached to the carbonyl carbon here is attached here. And it's time for a public service announcement from me, Dr. White. Remember, how many bonds to carbon are there? 4, 4, 4, 1, 2, 3, 4. And when you're making reactions or changing or writing structures, make sure all your carbons have 4, oops, let's fix this, 4 bonds to carbon. Because if they don't, it's going to be wrong. The other thing you should remember for test number 3, do you break carbon-carbon single bonds? No. I'll say that again in slow motion. Do you break carbon-carbon single bonds? No. So slow motion. Remember that. That'll help you on test number 3. All my tests in the final, but test number 3 is coming up. All right. Now, You can also have base hydrolysis of an ester. And here I have an ester reacting with a base, MOH is a hydroxide base, or for my class M can be lithium, sodium, or potassium and water. Now, as you learned up here, carboxylic acid reacts with base, gives you a carboxylate anion. Therefore, if you react an ester with base and water, the carboxylic acid that's formed immediately reacts with the base, any base present, there will be, to form this carboxylate anion, not the carboxylic acid. The fastest reaction in chemistry are called diffusion controlled reactions. As soon as the molecules touch, they react instantly. It's in a nanosecond or less. That's real fast. And therefore, whenever you have an acid with base around, you will get the carboxylate anion. Now, next one, you know, Dr. White's happy because we're working with a Grignard. I don't have down here, so I better write it down. In the Grignard right here, X can be chlorine, bromine, or iodine. And here we have the carbonyl of the ester. We're reacting with not one, but 2 moles of a Grignard, second step, acid and water, and you get 2 products, 2 alcohols. And the first alcohol is where you have the R group and the carbonyl carbon, and you do that special thing. You make not one, but 2 carbon-carbon single bonds from the Grignard. Now this part here gets kicked out and becomes the alcohol you would have used to make that ester. You know something? Let's practice this because it's fun. Now you know I'm an organic chemist. So let's look at this reaction. What do we have going on? Remember, look for what's different. That's where all the fun is. And here we have an ester. And we're reacting it with 2 moles of a Grignard. Remember, X can be chlorine, bromine, or iodine. In our case, it is iodine. And second step, acid and water. Here's my carbonyl carbon. The R group is attached to it. We'll have an alcohol, OH group, and then to the 2 R triple primes, they'll be bonded to the carbon in this alcohol that has the hydroxyl group. And you get a second molecule from this right here. You get ROH, this alcohol. And if we look here, what's our ethyl? What's our prime? Ethyl. Ooh, what's our triple prime? Ethyl. So I have my carbonyl OH, R is the ethyl. I'm going to make those 2 carbon-carbon single bonds. Hold on, I've got to rewrite this so I have enough room. Now attach this carbon are my R triple prime, making that very special carbon-carbon single bond, not one, but two. And remember, there are 4 bonds to carbon, so I can put in the hydrogens. That's a 3. And then the R prime becomes this alcohol, and that's an ethyl. And there you go. And that's the fun part of using a Grignard, 2 of them with an ester, to make this very complex alcohol here. And this you usually keep our prime small so you can distill it off easily. All right, next I was talking about an area that's near and dear to my heart because for many, many years I worked in this area. When I was at Axo Nobel, that's what it's called now. When I was there, it was called Axo Chemie, actually started out as RMAC, and that's the amines and their derivatives. Remember, derivatives is something made from, in this case, amines. And you have a different amines. That's where you take ammonia, NH3, and replace the hydrogens with R groups. And here's a primary, secondary, excuse me, and tertiary amine. I'll never ask that on a test. And how do you name those? Well, I only asked you to learn the common names. Name each R group as the alkyl group it is, and at the end, add the word amine. Now, when R is a benzene ring, this primary amine, again, like benzene itself, IUPAC said, these organic chemists have been calling this aniline for eons. We better make it the IUPAC name, and they did. And I won't ask on test 3, but aniline is an important chemical that's used to make other things like dyes and urethane foam and other chemicals. Now, something really near and dear to my heart is a quaternary ammonium salt. That's when you have a nitrogen with 4 R groups. It'll have a positive charge. All molecules have a net 0 charge. So we'll have an anion. For this class, I'm sticking to the halogen anions, X minus. There are others I've worked with, but for this class, I'll stick there. And quaternary ammonium salts, the common name, name each R group as the alkyl group it is in the front, and then add the words ammonium halide. Now, if X is bromine, it would be ammonium bromide. If X is chlorine, it would be ammonium chloride. If X is iodine, X minus is called ammonium iodide. And why is this near and dear to my heart? Because I worked for the company. I was in charge of all research in North America for one of the areas making nitrogen derivatives, including the most important, quaternary ammonium salts. Why? Because quaternary ammonium salts are the key molecule in fabric softener. If you go back, and I think it's in the videos, I talk about how I work with Procter & Gamble and also Lever Brothers. I think I talked about the Snuggle Bear, how that was found. And remember, quaternary ammonium salts can be used as fabric softener. And I also told the story how about the best mouthwash for me is the one that has a quaternary ammonium salt, not the same as a fabric softener, but another one, because certain quaternary ammonium salts have antimicrobial properties. I have patents in that area. I should know about this, and I do. Now, while we're talking about this, ooh, I have a mistake here. This is an amine salt. Now, amine salts are named just the same way as quaternary ammonium salts, However, they have either 1, 2, or 3 R groups on there. If you have 4, then you have a quaternary ammonium salt. Now, how do you make an amine? Well, you take an alkyl halide, RX, X can be chlorine, bromine, or iodine, react it with ammonia in the presence of base because you generate HX that's neutralized. And on the carbon with the halogen, you now have NH2, a primary amine. Now, if you take a primary amine and react it with an alkyl halide base, you'll form a secondary amine. The bond to nitrogen is to R prime is to the carbon with the halogen. Same thing in the first reaction. If you take a secondary amine and react it with an alkyl halide, you'll now replace this hydrogen with another R group. Now, I don't have here, but I did talk about it. Nitrogen and you don't have to put this in when you're drawing, has a pair of non-bonding electrons. Well, it turns out under the right conditions, you can react those non-bonding electrons. And what's the right condition? Right here. And you can take a tertiary amine, react it with an alkyl halide in the presence of base to form this quaternary ammonium salt. And that's a reaction really near and dear to my heart because I work for a company that made multi-million pounds per year of quaternary ammonium salts, like for fabric softeners, antimicrobial compounds, and other end uses. One of them is called organoclays, which is very important in drilling oil. And it's also been used to make, nowadays you can buy mayonnaise in plastic jars because that plastic is treated with an organoclay and doesn't let oxygen in to make the oil and the mayonnaise go rancid. Now, let's move back here. Another really neat way to make a primary amine is take a nitrile, and this is a triple bond with 2 pi bonds, reacted with excess hydrogen. Remember, bracket excess, close bracket means you have all the hydrogen in the world that anything that hydrogen can react with will. In this case, the 2 pi bonds of the nitrile. And you use the same catalyst, nickel, platinum, or palladium, like you did for a carbon-carbon triple bond. You break the 2 pi bonds, and each atom of the triple bond, the nitrile, gets 2 hydrogens. And you can write it this way, or now you can see it's a primary amine. And when I started in the chemical industry, that was the reaction I was asked to do research to come up to make a certain product for the company I was working with. Now, I talked about quaternary ammonium salts. Now, primary, secondary, and tertiary amines are bases. And as I mentioned earlier, take an acid plus a base, you get proton transfer. This is classic acid-base reaction. Well, any primary, secondary, tertiary amine is a base. If I react it with an acid, you get a proton transfer and you make an amine salt. And here X can be an HX, chlorine, bromine, or iodine. And turns out, I don't know if I mentioned it in the video, a lot of medicine has nitrogen in it, amines or amine salts. And if it has an amine in your stomach where there's HCl, forms the amine salt, and it makes it more water soluble. In other words, it goes through your blood better, in your blood better. Now, and a derivative of amines is an amide. And an amide is a carbonyl with an R group. On the carbonyl is nitrogen, and on the nitrogen is R prime and R double prime. Now, for an amide, R prime and R double prime, or just one of those, can be hydrogen. And those are amides. And when I worked at AXO, I was responsible for research and also helping the plants. We made amides. Now, how do you make an amide? You take a carboxylic acid, react it with either a primary, secondary amine, or ammonia. Here, R prime and R double prime, one or both, can be hydrogen, and you'll get an amide. Remember, nitrogen, I forgot to mention, has 3 bonds to it in primary, secondary, tertiary amine and amides. In amine salts and quaternary ammonium salts, it has 4 bonds to it. Let's go back and look at this again. Amines, nitrogen has 3 bonds to it, but quaternary ammonium salts and amine salts have 4 bonds to it. Sometimes confuses students, but go back and review that. Amines and amides have 3 bonds. Quaternary ammonium salt and amine salts have 4 bonds. So if you see the name salt in an amine, ammonium salt, it's going to have 4 bonds. If you see amine or amide, it will have 3 bonds. How do you make an amide? Again, carboxylic acid plus either if R prime and R double prime are hydrogen, that would be ammonia, NH3, or R prime and R double prime, one or both, can both be alkyl. And do you break carbon and nitrogen bonds in this? No. And you get this amide. Now, once you get an amide, what can you do with it? Well, you can react it, and I'm just going to stick to one acid, HCl. Why? It's the acid in your stomach. And we'll come back to this reaction. If you take an amide and react with HCl and water, you get back the carboxylic acid you would have used to make that amide. But the amines, it's a base that you would have gotten here, reacts with the acid to form this amine salt. We'll come back to this reaction later in the semester because this is how your body breaks down proteins. Like if you had something with protein in it, if you're not a vegetarian or a vegan, if you had a hot dog or hamburger or steak or something with, I guess, tofu too, not plant protein, this is how your body breaks it down. And we'll talk about that later in the semester. Now, you can also do base hydrolysis of an amide. Now, remember, in both amides here, an acid and base, R prime and R double prime, one, both, or none, can be hydrogens. And with base, and I'm just going to stick to sodium hydroxide, you can use others, but for this class, that's all I have. And water, you get not the carboxylic acid, because in the presence of base, the carboxylic acid forms this carboxylate anion. So you get the carboxylate anion of the carboxylic acid you would have used to make this amide, but you do get the amine that you would have used because amine is base and it won't react with sodium hydroxide. Now, I talked about heterocyclic compounds. You should know what is the definition of a heterocyclic compound. And that's a ring with carbon atoms and other atoms, such as oxygen or nitrogen. And I asked you to just learn one heterocyclic compound. In the videos I talked about where you find heterocyclic compounds in your daily life, a lot of places, but I didn't ask you to learn that. But you should know how to draw the structure of pyridine. Pyridine looks like benzene, except one of the carbons in the ring has been substituted by nitrogen. And that reacts like a tertiary amine. And if you remember the story about the mouthwash, if you put a acetyl group R, long R group on there and make a chloride quat, that's what keeps my gums nice and handy in scoping the Walmart equivalent mouthwash. And that's it. We're done. Oh, let's do one more thing real quick. Let's have some fun. Let's play that fun game. Oh, this reminded me, you're not watching what I'm doing because I forgot to switch over. Let's play that fun game. Circle and name the functional group, 2 points each. And let's just do 2 of them. And that's an odd. Let me fix that. That's 1. Let's just do 2. And here 2 to use circle and name the functional group, 2 points each. And I'll let you try it. Hit the pause button if you need extra time. So I'm going to zoom through real quick now. Time's up. Hit the pause button if you need more time. How do you play this game? You look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. If we look at the first one, oh, look, oxygen here and here. What do we have here? An ester. How do we know it's an ester? You don't have to write this down, but I will. Carbonyl, carbon double bond oxygen, oxygen here. The carbonyl has an R group. The oxygen has R prime. Are we done? Oh no, look here, more oxygens. And what is this? It's a carboxylic acid. And how do you know it's a carboxylic acid? We have a carbonyl with a hydroxyl group and an R. And that part you don't have to write down, but I am for you. Now let's look at B. Look for what's different. Ooh, nitrogen here. Carbons, carbons, hydrogen. It's a secondary amine but I didn't ask you to learn that. This is an amine. Ooh, look, oxygen and a nitrogen, carbonyl, nitrogen, R prime, R double prime, carbons here are R. Remember R prime and R double prime can be hydrogen. And what is this? It's an amide. Are we done? No, another nitrogen right here. And what does this have? Well, this is 4 R groups, 3 methyls, and this CH2 here. They can be the same or different. Plus charge on the nitrogen, and I have my anion, X minus. Remember, X can be chlorine, bromine, or iodine. In this case, it's chlorine, and it's a chloride anion. And what is this called right here? A quaternary ammonium salt, which is near and dear to my heart. If you have, I think, 8 patents in quaternary ammonium salts, they'll be near and dear to your patents, your heart too. And that's how you play that fun game, circle and name the functional group, 2 points each. And with that, I'm going to say, don't forget, do the practice problems. I hope you have been. I hope you also really have been watching the videos. And with that, I'm done for tonight. Good luck on test number 3. Hopefully you won't need no luck, but don't forget, your friend on test number 3 is how many bonds to carbon? 4. Oh, I got to fix this finger. No, it's this way I got to fix it. How many bonds to carbon? 4, 4, 4. And do you break carbon-carbon single bonds? No. And remember, nitrogen, amines, and amides have 3 bonds to it. Nitrogen in a quaternary ammonium salt and amine salts have 4 bonds to it. With that, I'm done. And I'll say, gehen gesund. Remember, in Yiddish, that means go in hell. Gehen gesund. And I'm done. Bye. I've stole that from Granny of the Beverly Hillbillies. Look on YouTube, you can see it. There's some shows of the Beverly Hillbillies. Bye now.